Good to be back, everyone. We're starting up our second method of solving quadratic equations. We're going to look at something today called the quadratic formula. But before we even do that, we're going to look at our problems and remind ourselves, okay, how do we factor again? And really, okay, well, what if factoring doesn't work? Why are we using this quadratic formula and how? Our goal for today is to watch this video, to complete the notes and practice, and to submit it to Schoology. To start off, we just finished learning how to solve a quadratic equation through factoring. However, what if we cannot factor a quadratic equation like the example below? Our x squared plus 5x minus 2 equals 0. What multiplies the negative 2 but it adds to 5? There's really no combination we can come up with. Can we still do this type of problem? Because in the past, we've written down that we can't factor it out, or we've said it's unfactorable. This is true, but does that mean that it's not solvable? That there are not any numbers that we could put in for a variable and get it to equal 0? Well, that's the type of problem we're going to be focusing on today. Now, let's show what we know from the past 2 days to try and solve some of these problems by factoring. And remember, our quadratic equation is always going to be in the form ax squared plus bx plus c equals 0. In case you forgot some of the steps from last week, I put a nice little reminder up here. So that way we know we have to factor, maybe using greatest common factor, the A times C method, area model, or grouping. Then we have to set each piece equal to 0 and solve to get our possibly 2 solutions. Now, the reason I say possibly today is we might have some problems where there aren't 2 solutions. Let's start off looking at number 1. So I'm going to use the A times C method. So what multiplies to negative 50 but adds to 49? Now you can list out all the things that multiply to negative 50. I'm just going to quickly move ahead and let you know what I figured out. So what I'm realizing what multiplies to negative 50 but adds to 49 is going to be a positive 50 and a negative 1. Now just for, moving along with our factoring, I know that since my A value is 1, I can go ahead and just change this. So those are 2 binomials. So it's going to be x plus 50. It's going to be x minus 1. So I'm multiplying them. I set them equal to 0. Perfect. All right. So now I have to set each piece individually equal to 0, which is what I'm doing. And then I can solve for x. So I get x equals 1, and then I get x equals negative 50. So those are my 2 solutions. So that's a nice little reminder of what we've done the past couple weeks. Now let's try a couple of harder problems where maybe we aren't necessarily in the ax squared plus bx plus c equals 0 form. So let's look at number 2. How is this different? Well, first of all, we don't have all the terms on the same side. Everything doesn't equal 0. So that's going to be our first step. We're going to start to move this negative 5 over. Well, how do I do that? I add 5. So let's rewrite what I have. I have x squared plus 9x plus 5 equals 0. Now from here, you're probably thinking, okay, what multiplies to 5, adds to 9? Right now, this problem is not doable. This is one of those that we're like, okay, I'm not sure how to approach this. This is one of those that's like a to be continued. That's what we're going to look at today, because right now, we're not able to factor this from what we know. And not being able to factor means we're not able to solve it. So again, we're going to come back and look at this problem in a little bit once we've tried this new method, but hold on to that. Put a star by it so that way we know to come back to it. Let's try number 3. Ooh, again, well, we don't have everything on one side of our equal sign. We don't have everything set equal to 0. Now, you're probably thinking, okay, well, maybe I can move this guy over to that side and, I'll then have everything equal to 0. You can totally do that. That's fine. But my goal whenever I'm ultimately trying to do this, I honestly want to try to keep my A value as positive. I want my A value to be greater than 0. So what I'm going to do is I'm going to see if I can move the 20x and the negative 66 over. So in order to move them over, I have to take their opposite signs, right? So I have to subtract 20x from both sides. Now, if you want to do this in one step, I'm going to do it in 2 steps just to show you what I'm looking at. All right, okay, so then I want to move over the 66, so I'm going to add it. So I have 2x squared minus 20x plus 66 equals 0. Perfect, that's looking great. Okay, so let's see. Can I pull out a greatest common factor? Yes, I can pull out a 2. So I'm left with x squared minus 10x plus 33. That equals 0. Okay, so let's start looking at this. Okay, so what multiplies to 33 adds to negative 10? Ugh. We're kind of stuck there again. This is another one that's to be continued. We're not really sure how to approach these types of problems. Oh boy. Okay. We're going to have to come back to this type of problem. All right. Let's move on to number 4, at least figuring out how I can bring all 3 of my terms to the same side. Okay, here we go. Which side should I move them to? I mean, I brought everything to the left side so far. If I look at any of my previous problems, I brought everything to the left side. Do I necessarily have to do that? No, I could bring everything to the right side because we know both sides of the equal sign will hold no matter way. Now, remember, my goal is so my a value is positive. So it would make sense for me to add x squared to both sides. So that way I have 0 equals x squared plus 2x plus 7. And then I can go from there saying, okay, what multiplies to 7 adds to 2. Again, these are more to be continued type of problems. We're not sure how to approach this just yet. However, we do now know the importance of having, our ax squared, our bx, and our c all on the same side. And we talked about the importance of making sure that my a value is greater than or equal to 0. I mean, we're going to encounter problems in the future, maybe in geometry or in algebra 2 class, where your a value will be a negative. But for now, let's try to make it as positive as we can. Okay, so all these types of problems, we cannot factor, but are we able to solve them? We are. So let's go ahead and go to the next page. All right, here we are on the next page. So now that we've reviewed solving by factoring, we're going to go back to the basics of ax squared plus bx plus c form. So what we know is that all quadratics, they take the form ax squared plus bx plus c. We know that. That's pretty important. So for the problems below, we're going to focus on identifying what's the number in front of x squared. That's our a value. What's the number in front of what's the number in front of x? And then what's our number, our constant by itself, c? Hey, c stands for constant, so that kind of makes sense. So let's go ahead, let's look at the problems below and see if we can actually label the a, b, and c in each problem. So let's start off with our first one, okay? So looking at this, I can see my a value is 5. It's the number in front of x squared. Then I can see my b value is negative 30. Don't forget the negative in front of it. And then lo and behold, my c value is just going to be 50. I want you to go ahead and complete number 6 and 7, doing the same thing, label a, b, and c. Pause the video here so we can check in after. All right, let's check your answers. Let's start with number 7. So our a value should be 1. Don't forget, you can always put an imaginary 1 in front of any variable if there's not a number there. Our b value is negative 6, and our c value is 13. Now going back to number 6, I see my a value is 9, but here's the tricky part. There's no x value. It's tricky because when I essentially don't have an x value, that's the same as saying plus 0x. So really my b value is 0 here. Everything just doesn't scoot up. Like my b value is not going to be 12. My c value, my constant, will always be 12. So just keep that in mind. Now that we've approached that type of problem, let's go back to that initial problem we came up with. The x squared plus 5x minus 2 equals 0. Let's go ahead and identify a, b, and c for this quadratic equation. So you go ahead on your paper in front of you, label a, b, and C. I'm just going to go ahead and do it right on my equation itself. So that way I know my A value is 1, my B value is 5, and my C value is -2. Okay, so what's the purpose of knowing the A, B, and C values? Well, that's going to help us in our next case. Now we know we cannot use factoring to help us in solving this problem. Therefore, we're going to use something that's a different form. It's called the quadratic formula. And as you look at it, you're probably like, whoa, Nelly, that is huge. Like, what is that? How do I even read it? Well, looking at this, all right, this formula was actually derived by one of the famous mathematicians that you probably know of, Pythagoras. Yes, he actually did create the Pythagorean formula. He was able to take the general quadratic equation, the form ax squared plus bx plus c equals 0, and he manipulated it and solved for x. That's how we get this formula, where x is isolated by itself. So it's kind of nice the mathematicians ahead of us did all this legwork. So we can read it as x equals, we can say negative b, some people might say the opposite of b, as in taking the opposite sign. Then this sign right here that you're probably looking at, you're probably like, what does that even mean? That means plus or minus. Plus or minus. This idea of plus or minus takes into consideration that we might have two solutions that come out. We'll talk more about that later, but plus or minus. Then it's the square root of everything underneath it. Square root of whatever b is squared minus 4 times a times c. And then the whole top part is all divided by 2a. So really, us labeling initially in our problem our a, b, and c values, that's what we're plugging into this quadratic formula. Our b value in this case is 5, is going to go in the spots where we see b. Our a value of 1 is going to go in for a, and then our c value of -2 is going to go in for c. All right, looking good. Okay. So let's try using this quadratic formula on our problem above. All right, let's try using that. So here we go. I usually like to write down the quadratic formula every single time, the original one before I plug anything in. But since we have it right in front of us, I'm not going to do that this time. Okay, so we're solving for x. Ooh, let me try that again, not with a highlighter. So let's solve for x. It's going to equal the opposite of b, or taking the negative of, +5. So it's going to be -5 plus or minus, keep that there for now, plus or minus the square root, and I extend that square root sign a really, really long ways because I have a lot that I'm putting underneath it. Okay, the square root of b squared. Now, I always like to put this b in parentheses because in case it's a negative in the future, I like to make sure the whole thing, even that negative number, is squared. All right, so b squared, so 5 squared, minus 4 times whatever our a value is, which is 1, nice and easy, times our c value, which, remind me, is not just 2, it's -2. Okay, and then this whole piece here is all divided by 2 times whatever our a value is, which is 1. Okay, now we want to simplify this a little bit because this is, that looks very, very complicated. So that's really going to be kind of our next step. We, find out what a and b and c are, we plug them in, and we're going to simplify to see what our result is. So there's nothing I can do with this -5 for starters, so I'm just going to keep -5 plus or minus. And then I'm going to take the square root of those values. I'm going to try to make it a little bit simpler underneath it. So now let's go ahead and simplify this even more. So we have 25 from b squared, right? And we're subtracting 4 times 1 times -2. Now I'm kind of following the order of PEMDAS, so I'm doing, the exponents first, then I'm multiplying. So I'm going to multiply all three numbers together. So really, I have 4 times 1 times -2, that's -8. But when I subtract a negative, that makes it positive. So really, I'm adding 8. You could also consider it as -4 times 1 times -2, which is a positive 8. Okay, so that's looking good. All right, now let's go ahead and divide it by 2. Now, sometimes I know we can easily erase our extended square root sign. I'm okay with, making it a little bit longer than needed because I just want to make sure everything is under the square root, not just the 25, but also the 25 plus 8. All right, let's keep going. Here we go. So nothing I can do with that -5 yet, so -5 plus or minus. Let's add together 25 and 8. Let's see what we got. We end up getting 33. Oh, there we go. Everything's divided by 2. So if you're looking at this problem like I am, and you're thinking there is not really a square root of 33, you are correct. This square root of that specific number really is why we're doing the quadratic formula. What we're going to realize is our answers, our x values, our solutions, they're not going to be whole numbers. If they were able to be whole numbers or easy fractions, then most likely we would have done some type of factoring. But in this case, it's hard to take the square root of 33. It is. That's where we got to have our calculator. So looking at this problem, okay, we want to make sure that whatever the decimal is on the square root of 33, we want to make sure that we're adding that, or we're going to see, or we're subtracting that to -5. So when I simplify what's underneath the radical, what's underneath our square root sign, I like to break this down into 2 parts. This is where we're really targeting that plus and minus sign. I'm looking for an x value where it's going to be -5 plus the square root of 33 with everything divided by 2. And then I'm also looking for an x value where it's -5 minus the square root of 33. And everything's divided by 2. So that's kind of the idea of where our 2 solutions come from that plus or minus sign. So now, this is the important part. I'm going to show you how to put this in your calculator. Now, I'm going to be referencing a graphing calculator. This is the best result possible. But if you don't have a graphing calculator and you have, a 4-function calculator, that should be fine. Just be mindful when you're putting results in. I'm going to be using some parentheses to kind of help you out. If you're not able to use parentheses, then make sure you're just going step by step by step. So for me to put this in my calculator, I'm going to choose a different color to kind of help us out. What I'm going to do is I'm going to first start off putting a parenthesis. Then from after that, I want to start typing in -5, and then I'm going to hit my plus sign. And I'm doing it with you as well. From there, you're going to hit the second button, and then you're going to hit where it says x squared. So we're trying to target that square root button. So something's going to pop up like this with a parenthesis already. Go ahead and type in 33 after that. And then you're going to close the parenthesis, which means we're closing the square root sign. We're just taking the square root of 33. Now, we want the square root of 33, but we want to add it to -5. So what we're going to do is we're going to add another parenthesis on the end to make sure we group everything in the numerator together. Then you can hit your divided by sign, and then you can hit 2. So really what we're going to do is we're going to do the same thing with our other x value as well, but instead of a plus sign, we're going to have a minus sign. So you're essentially typing in the same thing again, but we're going to get 2 different results, like I said. So let's just start off with our first x value. When we put this in the calculator and click our equal sign, we're going to get this kind of, this decimal number that's not going to be exact. You're probably thinking, ugh, I got to round. So let's start looking at this. Okay, so I get 0.37228. Okay, let's round maybe to nearest tenth. So that's 2 decimal places. So it's 0.37. All right, and we're going to go ahead and take the time to type the other results in our calculator. I'll let you go ahead and practice typing that in right now, and then we're going to see what we get as our result. All right, I'm going to start writing down our result. It's actually a negative number because we know we can have negative numbers that go in there. and we get something kind of along a similar decimal to the other one. That's okay, but if we want to round to 2 decimal places, it's going to be negative 5.37. Those are going to be our solutions. Those are our x values. Now you can see it would be impossible to actually factor with those because they're decimals. There's no way you could come up with that type of number. So what have we learned? We can use the quadratic formula right up here to help us figure out how to solve quadratic equations when they aren't factorable. Figure out that result. Now, for this third page, I'm going to go ahead and try some of these examples with you with our steps. Don't worry, I have the steps labeled right next to here so we can go through them, starting off with labeling A, B, and C, plugging it into the formula, and simplifying to get your possible solutions. All right, so let's go ahead. Let's look at example 8. So let's start off labeling A, B, and C. My A value is 1, my B value is 9, my C value is 5, because they're all on the same side of the equal sign, looking good. Okay, and then we're going to plug it into that formula. So just for practice, I'm going to write down the actual quadratic formula, so that way I can start getting it into my head. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now let's plug in what we know. Opposite of b, or negative b, is negative 9, plus or minus the square root of 9 squared minus 4 times 1 times 5 all over 2 times 1. Let's simplify this. Negative 9 plus or minus the square root of 81 minus 20 all over 2. Let's keep going. Negative 9 plus or minus the square root of 61 all over 2. And then this is where we can kind of break it up into, two pieces where we have x equals negative 9 plus the square root of 61 over 2, and then x equals negative 9 minus the square root of 61 over 2. I'm going to have you go ahead and right now try plugging in those values into your calculator. Let's see if you can plug them in correctly with parentheses and see if you can get your results. Pause the video here and we'll check it on out. All right, go ahead and check your answers with mine. Did you get negative 0.59? And did you get negative 8.41? Remember, it was 0.405. The 5 rounds it up. Hopefully got those as your answers. All right, so let's go ahead and let's try our next problem using the same steps. So let's start off by labeling A, B, and C. And then I'm going to write down the quadratic formula. I don't expect you to have it memorized just yet. You can reference your notes for that, but don't worry, we're going to work on memorizing it in the near future. I got a catchy little song to help us out with that next week, so no worries. All right, and then we're going to go ahead and plug in what we know. The opposite of b, or the opposite of negative 6, is a positive 6 in this case. And then we're going to do plus or minus. It's going to be negative 6 squared. So this is the importance of making sure that you have the negative sign inside the parentheses. All right, so minus 4 times 1 times 1. Got to extend that a little. All over 2 times 1. So we have x equals 6 plus or minus. It's going to be 36 minus 4 all over 2. So x is equal to 6 plus or minus square root of 32 over 2. Now, I know you might not have a whole lot of space. I know I kind of tend to write a little bit bigger, but